When starting a multi-site study, institutions will agree on a protocol for data acquisition before the subsequent analysis. In practice, scanners across sites behave differently due to differences in vendors or software versions. Even importing scan cards will not guarantee the equivalent protocol due to these differences. These differences can be accounted for using data harmonization before the analysis, but this is challenging and has its own limitations. If we were able to validate that what we were acquiring was what we expected, we could avoid these problems. In another scenario, instead of aligning institutions, we might align ourselves with community standards for a specific domain, like quantitative susceptibility mapping, for example. We'll acquire our data, hopefully following these guidelines, but in practice they're easy to overlook or require domain-specific expert guidance. And without this, we'll have a flawed analysis. If we could validate how well we followed the guidelines, we could avoid this problem. So introducing EasyVal. This is an open source tool for validating incoming DICOM sessions interactively to produce a compliance report. So what do the references we're validating against look like? Well, a reference could be based on a previously acquired reference session, and EasyVal provides an interface to convert this into a JSON format that describes the fields and values that we care about, that we want to validate. Alternatively, we could use domain-specific guidelines like those described in QSM, or try to follow the settings used in landmark studies like the Human Connectome project. For these, we encode these more complex and flexible guidelines into a Python format that can be used as a reference. And so what does this Python format look like? Well, in the case of QSM, which earlier this year had this guidelines paper released, they describe a set of rules for acquiring QSM data. EasyVal can read Python files that contain these simple validator functions that describe these kinds of rules. So for example, this rule requires that the spacing between echo time values be uniform, and I've encoded this rule verbatim as a validation function, and we can see exactly how it's determining whether that rule was followed. So EasyVal, it's a web interface that provides a means of generating a reference based on a session or checking incoming data for compliance with a reference session or with community guidelines. But EasyVal also depends on some underlying tools we developed, including a Python API and a command line interface. But let's have a closer look at the web interface with some examples. So here we have the interface to generate a session reference, and we've chosen a DICOM folder representing our session. The acquisition fields here specify which combination of fields will uniquely identify each acquisition. Usually this is just the protocol name, which this is set to by default. And the reference fields here specify which fields we actually want to validate in future compliance checks. So here we've said that we care about validating the echo time and the magnetic field strength. So now we can generate our JSON reference. When we click generate, it reads the DICOMs locally and displays the fields and values you've requested in a way that lets you review and edit them before downloading the JSON file. To check compliance, we move to the next tab, and we've selected our incoming session folder. We've said that we're going to use a custom reference, the one that we just generated, and then we specify that reference. And finally, we click generate. In this case, we can see that we had an echo time value of 5.84, but the reference specified a value of 8 with a tolerance of 2. So it didn't pass this particular check. Taking a step back, we could have also validated our data against guidelines like the QSM guidelines that I mentioned earlier. And here we have a similar report. This time we can see the outcome of all validation logic that describe the rules from the guidelines paper, including tests that passed or failed. Perhaps best of all, EasyVal is built using Pyodide and WebAssembly. That means that you can run it in a web browser without installing anything, and without even uploading DICOMs. So everything runs locally. And this makes it well suited to clinical environments where data privacy is critical and software installation is limited. So EasyVal validates DICOMs with either a reference format that can be generated in the JSON format or against community guidelines in the Python format. And the underlying pip package DCM check was developed to provide this underlying functionality. Thank you very much for having me here for MRITogether, and thank you to my group here at UT Austin and back in Brisbane at the University of Queensland.